Alright, welcome to my newest LeetCode video where I take you through my process for how I solve a problem for seeing it for the very first time. And I'll just go through my normal processes like I would for a real technical interview. And, as it's my first problem of the week, I'll start with an easy, just as a warm-up. So let's just pick a random one that I haven't seen before. Let's get the timer ready, make sure this is all nice and evenly squished. And let's begin the timer before I even start reading. So, number of students doing homework at a given time. We are given two integer arrays called start time and end time, and an integer called query time. So the students started doing their homework. It's the time, start time, the element of start time, and finish it at time, end time, I. So we want to return the number of students doing their homework at time, query time. And formally return the number of students where query time lays in the interval start time, end time inclusive. What does that quite mean? AKA return the number of students where query time lays in the interval. I'll just copy that. So yeah, the ith student started their homework at the time start time I, at the ith element of start time, and finished it at the ith element of end time. So straight away, for a brute force approach, which we can just think about first, and actually before we do that, we should look at the constraints in the examples. Sorry, that's my mistake. So yeah, the start time is always the same size as end time. They're both between 1 and 100 elements long, so it's not too long. The times themselves are just between 1 and 1,000, which is pretty simple. And start time is always before end time, so we don't have to worry about that. And query time is also just between 1 and 1,000. So this doesn't look like we need too much of a super efficient approach, which should be good. So for this example, when start time is 1, 2, 3 and end time is 3, 2, 7, and query time is 4, we have to put 1 as 4 is after 2. No, sorry, 4 is after 3, so 4 is after the third student starts and before the 7th student started. So that student is doing their homework, but the second student started their homework and finished it at the same time, which is not 4, so that student was not doing their homework, and 1 and 3, they weren't doing their homework at 4. Yeah, so straight away, what we can do for this one, brute force approach, could be to just iterate over start time and end time at the same time. If each the current elements, if the element of start is less than query time. I'm trying to write this out not too verbose and too long, so we don't waste too much time. And hopefully I'm not getting cut off by my face cam here. We're gonna iterate over start time and end time at the same time and check if each of the element of start time is less than query time and the of end time is greater than or equal to. That should work. the time complexity of that, which is always good to mention before you even start coding. Well, you only have to iterate over start time and end time once. So it's big O of n plus big O of n to get over each one. Yeah, where n's just the size of either of them. And then checking if query time, if it's less than or equal, is constant. So that's just plus constant, which equals plus n. So the time complexity would be big O of n, as I explained, where n is big of start time or end time. Space is constant because we don't need to keep track of anything. So we want to initialize our variables. At the start, I just like to add my comments before I even get into coding anything in an interview, so I'll do that here. And then we just want to iterate over start time and end time. Check each one. Add to counter if we need to. I don't need to do that. So we need a result variable. We just call that res. Starts at 0. Do we need anything else? Or we can just have n as the size, just so it's a bit easy to read. So if we just go from I equals 0 to n. I'm just trying to think if we can do a range-based loop instead. I don't think that's necessary. No, we can't do that actually, because we have to go through both of them at the same time. I'm not sure if there is a way to do that in a simple range-based loop, but this way is easy. So we just do if start time I is less than or equal to query time, and time I is greater than or equal to query time, and then we just res, do that, otherwise nothing. Result. As far as I should know, that should work, so let's just run the tests. Okay, that works. I can't think of any reason why that wouldn't work. We'll submit it, see if it works. And it works. In 7 minutes and 8. I like to give myself the benefit of the doubt when I finish writing the correct answer and it's confident. So I'll say I got an accepted solution in 6:59 seconds, because I'm pretty sure that's when I typed the last thing. I like to just give myself any sort of help that I can. But what I like to do after that, so what I do with these problems is try to get any sort of acceptable solution that I can submit, and that will be the timer I give myself. And then I'll go back over and see if there's any improvements to be made. So let's just think about this. Can't think of a possible way. There could be a possible way to improve over our time and space complexity. We have to iterate over start time and end time. Well, I mean, if the ith element of start time is not less than query time, we don't have to check that in time, and vice versa. So I mean, we could probably do tiny little optimizations. I mean, I'll try that maybe. I'm not sure if it would be faster, but I think it's good practice. So if start time I is actually larger than query time, we just continue. And the same thing, whoops, start time. And the same thing for end time, if that's less than query time, we would continue, otherwise we would just increment the result. would that be faster? I suppose, because we don't have to check. So it's that. We don't have to check the end time if the start time is, you know, invalid. Hold on, is it? Does start time and end time come in order? Doesn't really say if they're sort of ordered. No, 3, 2, 7. Or does start time come in order, maybe? I mean, in an interview, that's something that you could ask. Funny part about these problems is the naive approach would be deployed for production 100% of the time. Yeah, I have heard that in the actual companies, an acceptable solution is normally fine, and then you don't only really worry about improving the efficiency or anything. If you need to, I read it somewhere. There's some quote that's like what's it? Something like you take correctness over efficiency, maybe, or I cannot remember. It was something like that. You take one over the other unless there's a legal issue, and then like you'd need the correctness to be true. I cannot remember. I tried to be impressive there and I couldn't think. I don't know if this part's even needed. I don't think we'll need to check that because I think this is fine to leave it like that, right? I am curious if this sort of runs any faster. I know the I know the submissions. Whoops, that's not good. The submission timing and space things are pretty varied. Like it says 3. It's just taking 3 milliseconds. But I mean, we have made a tiny. I guess that should be a tiny. Yeah. So I'm not sure how what's the word, trustworthy, reliable that increase is. Yeah, I don't think you can do better than big O of n, no. I think that's the lowest, is it conceivable runtime that they say is the proper term? I'm just trying to look for any sort of small optimizations I can make just for a bit of practice maybe, but I don't think I can. I'll look at some solutions, see if anyone's ready. 3 ways. What 3 ways? Whoa. I mean, yeah, isn't that what I did? Yeah, that's what I did, and it just, well, that diagram makes it look a lot more confusing than what it is. So that's just sort of an approach that you could use to find it later.